to start.
Yeah, sure.
Yeah,
So,
please.
yes, Professor, we are live now. You can start.
Okay, thank you. Um, just give me one moment. I have some issue. Yeah, no problem. Yeah, now it's fine. Okay, thank you. Okay, welcome and good morning to everyone. So we are having our third live interaction today. So the purpose of today's interaction is, of course, to get to know how the course is treating you and to get a live feedback from you and, of course, respond to any concerns you may have in the process of learning. And if you have concerns about your assignments or examinations, you can ask that. I want to believe that everything is going smooth. And next month, you're going to have your final examination. And I also hope that you are learning quite a lot of things which are both theoretical and practical. And by and large, you must be hopefully enjoying doing your assignments and, of course, going through the lectures and other reading materials. The reading materials are very important for your final examination, not just the lectures. So do read them. And there is no substitute for self-study, okay, or reading and contemplating on your own. Okay, lecture is one, but you need to read and develop more understanding in order to fare well in exam and also fare well in career. Okay, so today's session, I will dedicate the latter part of the session for uh, responding to your questions, if any. We haven't got many questions from the chat box, so that shows everyone is happy with everything. And if you have anything now, we will, of course, respond to it. And yeah, so let me okay. And unfortunately, I don't see many participants today. I don't know. I think just 13, and that includes some of us. So therefore, the numbers are very less. Nevertheless, this is being recorded, and those who are missing it will get it online. Okay, so since this course is about business intelligence and analytics, okay, and we already know that data is the raw material for business intelligence and analytics, or in order to generate insights for decision making, we actually model data. Okay, so one is the raw material or the input that goes into the models, and that the other is the model itself. Okay, so a model which is a skeleton actually gets its flesh from data, or it gets trained using training data. And of course, we extrapolate it using test data. So we have seen all those processes involved in analytics. But let's ask a different question in this session as to where does this data come from? Okay? Data is the resource for analytics. But the source of data, we just say it is database. Okay? Well, database is a technology. Okay, we cannot say, looking at a home, we cannot say the house is the home. No, house is only a infrastructure where people live. Okay, so to be accurate, data is what resides in a database. Okay, so database is not data. Database is only a technology to store data. So the real raw material is actually the data. Okay, and our question today is, where did this data come from And are there some things or some concerns that we should have when we handle, when we use, when we analyze, when we report this data? What are the concerns, particularly the ethical concerns? So I'm underlining that term, ethical aspects, okay, of data mining today, okay, ethics, okay. So let us move on to understand some nuances of it. Okay? So, so I'm giving you a picture of the flow of data from an organizational perspective. Okay? So, organizations, be it government, be it semi-government, be it business organizations, be it not-for-profits, be it a temple, be it a church. So all these organizations, be it an educational institution like ours, they all collect a lot of data about whom? About data subjects, okay? Or individuals, okay? Humans. Okay? I'm not suggesting that humans are the only source of data for organizations, but humans are a major source of data, okay? And what kind of data about humans? Humans' personal data. Oftentimes, what is used in analytics is about your behavioral data, okay? Your personally identifiable data, meaning that your ID or ID related data, which can be used to identify you, okay? And then when your data is attached to your identity, that becomes your data, okay? And that particular data is actually collected by an organization, and it is stored in an organization's database, okay? That is one possibility. And the organization, if you're working for an organization, you're an employee, so the employee database has your data, meaning your demographic data, your data about your education, your family, okay, and a lot about your performance, etc. Okay, even your health to some extent, because organizations may provide you insurance and related services where your health data is also captured. What does that mean? Okay, the organizations have captured a lot of data, which is actually used for which is ideally used for the purpose for which it is collected. But organizations can also do data mining, as we have seen. Okay, they can profile you, and then based on your profile, they can actually make recommendations for you. Okay, which is the common or widely used application of analytics in customer analytics. Okay, use your data. Okay, it could be employee analytics, it could be customer analytics. Okay, and an organization which collects your data and stores your data and takes decisions about your data is known as a data controller. Okay, is a data controller. Okay, so there is a data subject, you. There's a data controller, which is an organization which collects data about you. And we also know that an organization may share that data with an external agency or an analytics firm. Okay, here is where analytics actually may happen. And analytics could be a processor, a data processor could be an external agency which receives your data, analyzes your data, and then shares insights from the data, or output from the models with the data controller for decision making. Okay, so the decision makers may be here, but the data analysis is done elsewhere. But now you see a problem here. You don't see problem here. You only are excited about analytics, okay, and applying algorithms. Okay, you may be working here. Okay, this is your dream job, but you should know that you're handling personal data of individuals, which is shared by some other organization. Okay, so today, since there are chances that organizations can handle personal data, use personal data, and also misuse or abuse personal data without the consent of the data subject. Okay, therefore there are ethical concerns, okay, about the use of data. Not just ethical concerns, but legal concerns. Okay, and you know that it has culminated in certain laws and regulations in recent times. Okay, some of you must be aware of something known as GDPR, which is a regulation for personal data protection in the European Union. And last year, you must have heard about enactment of an act in India known as DPDP, okay? Digital Personal Data Protection Act, okay? DPDP 2023. Essentially ensuring that data collecting or data controllers and data processors should pay attention to the privacy concerns of data subjects. Okay, so there are legal norms today which should be followed, or rule or laws today which should be followed when handling the data of private individuals. Okay, so all those who are involved in analytics, I would strongly suggest that they go through GDPR, which is about EU nations. When you are dealing with a client which is in European Union and you may be based out of India, handling the data of European Union citizens, you must be aware of data protection guidelines or regulation of that country. Similarly, in India, we have DPDP. So what are the guidelines in DPDP? This document is available online in Ministry of IT. So do go through them, and it is out of your own interest. It's not a part of the syllabus of the course, but as a general interest, you should be aware of data privacy and data privacy regulation of a country from which you are actually sourcing data for analytics purpose. Okay. Another important aspect of the ethics of data mining and analytics is the current development in technology. Okay, we are actually discussing machine learning, or in short, ML, and AI is an associated term. Okay, artificial intelligence. Okay, so artificial intelligence is a particular technology which is developed by a computer scientist, and it is closely associated with machine learning. AI depends on the type of algorithms that you use. You are soon going to learn a learning algorithm which emulates human brain, known as neural networks, okay, or artificial neural networks. Okay, you have week dedicated to neural networks, understanding what are neural networks, what is the structure of neural networks and how it emulates the human brain, and how a neural network is trained. Okay, so one of the key learnings you will have very soon is that a neural network, unlike a regression or a decision tree model, it is a black box. Okay, you cannot understand easily what is the structure, or what is the how the model actually is structured, or you cannot easily interpret it like y equals bx plus c, a simple linear regression. Okay, here if you actually estimate the model parameters, you can easily interpret the model, okay, and explain to a decision maker why you got a particular output. Okay, but in the case of neural network based models which are used in AI systems, it is not easy to understand. That is one aspect. And also, by now you know that a model will behave based on the training data that is used to build the model. Okay, for example, if you are training a decision tree for say predicting fraud in using data from the United States, then it will actually will best perform in that country. Whereas if the data is collected from India, it will perform in India based on the historical data. But if you actually deploy a model that was developed using Indian data in America, chances are that it may not perform in the right way. Okay. So therefore, generalization is a problem for algorithms which have been trained using a particular set of data. Okay. And so therefore, there is also an ethical concern because you can train a data using the data that you choose to train it. Okay. Therefore, it is the developers or the designer's mind that decides how the AI system is going to behave. Okay. And this particular aspect could also be misused. Okay. When you actually train a model using a data that is intended with certain malicious project or purpose, then it could misbehave. Okay. And that could lead to ethical concerns. Okay. So I have shown here, or I have given you a link to a YouTube which you can actually watch later. I'm not running the YouTube, but Shashi Tharoor is a member of parliament, about, and of course, he has a lot of interest in social media and technology. So he recently gave an interview in a literary festival in Trivandrum. Yes, Trivandrum. So the interviewee was he himself, and the interviewer, okay, was a AI emulated model of him. Okay. It's a what we call a deep fake. Okay. So the interviewer is actually asking questions like in the same voice, in the same tone, with the same bodily gestures as the person himself. Okay. So this was basically to help people think about the future of technology. Okay. People can be faked today by using data, okay, voice data or historical data, okay, behavioral data, okay, that is what define yourself, okay, and it can be used to create your own twin or yourself, okay, and what are the ethical future implications of it? Okay? Actually, I'm not. The particular show was only to throw light on what could be future and what could be future implications. Okay, so we will come to it in a while, but ethics is an important aspect of doing business, and literature suggests that in order to be ethical in say in business or in any role, there are three key requirements. Okay, this is a sort of abstraction. One, it must be possible to choose between different options. Okay, when you give options to a customer or an employee, so as an individual, one should be able to choose. One should not be forcing a particular option. Okay, the choice is very important, and it's a part of freedom. Okay, freedom to choose, or options should be generated. And second, there must be some societal consensus that at least one of the possible choices is socially beneficial. Okay, so when you generate various options, these options will have social impact. Okay, and therefore at least one option. Okay, business can generate many options. Some of the options could be only for profit and they may not be concerned about society. But in those generating options, at least there should be one which is socially beneficial. And third, what is suggested is the agent must be able to recognize that socially beneficial action and take the explicit decision to choose that action, which is ethical thing to do. So ethically correct options should be available when you create new systems. Okay, and the absence of which can have adverse social impact. So it is basically these guidelines are enabling developers and designers to think while they train algorithms and develop AI systems. The social impact should be understood, and decision makers and people who use them should be able to take the right decisions. Okay, I have given a few blocks below which only depicts various concerns, okay, or various aspects of AI and ethics. Okay, this is from Microsoft. So fairness, reliability and safety, privacy and security. We talked about what is privacy already. Inclusion, meaning different types of people, okay, abled or disabled, okay, man or women, okay, rural or urban, should be included in the program, okay. And then transparency, okay, how, for example, how your data is going to be used if data is collected from you, okay. And accountability as to if something goes wrong, where you actually trace it, okay, who is responsible for it, should be attributable. So these are some key concerns when it comes to ML, AI, and ethics. Okay. Well, machines are trained with data, and algorithms reside in the machines, and you engage with your smartphone, and a lot of algorithms are actually engaging with you, and they appear as if they are humans, right? And and Alexa, listen to your hey Siri. No, yeah, my Siri is activated, right? It has been go to sleep. Okay, you can send Siri to sleep, or you can invoke a voice agent to respond to you. They talk to you like machine. They talk to you like humans, but they are actually not humans. So their emotions are fake emotions. So to what extent it is ethical is still a debate. Okay? But beyond that, when you can design and develop algorithms.
I don't see any smart home accessories connected in your home. I can help once you've set something up in the home app.
Siri, hey Siri.
Good afternoon.
Okay, I have a problem now. Siri is activated. I called him. Okay, I have to send. Okay, it went back. All right. So these agents act as if they're machines talking to you. Okay, so you can actually get misguided if you are not aware of what is the function of them. A lot of people could be naive, and society can actually have negative impact because of the algorithms you train and send out into the market. Okay, so these are broad ethical concerns I'm presenting here. Yeah, so now there is an important area that is developing alongside AI and ML that is known as responsible AI. So basic question is how you retain your responsibility to society while you develop ML and AI for human convenience or human decision making, etc. Okay. So that requires more transparency, more accountability. We saw some important key words in those blocks in the last slide. Here, let me actually give you an example. Okay. Here is a neural network algorithm. You will be learning it very soon, which actually learned a rule from training data. Okay. The training data is about pneumonia patients. Okay. So those who have pneumonia and those who also have a case of asthma, okay, pneumonia patients who has asthma, okay, patient X who is contracted pneumonia and also has asthma. The algorithm found that they have low risk. You present this finding to a doctor, okay, and doctor will be shocked. And doctor will not accept it because it goes against medical science. But this is data. This is the data that is presented to the algorithm, and the algorithm learned this rule. You know how rules are learned in decision trees? In a similar way, a neural network will also learn these rules from the data. It's a pattern that emerges from the data. So can this rule be used by medical practitioners? If a pneumonia patient comes with an asthma case, well, it's a low risk, don't admit the patient, okay? treat the patient and treat the patient as a low-risk case. Okay? This can be very dangerous. Okay? So therefore, there is a need for algorithms to explain why this rule. Okay, and that is known as, there are two concepts here, interpretability and explainability. Okay. Can someone imagine how this rule got extracted from the data set? This rule is actually a valid rule. Okay, so the neural network learned the right rule. Okay, but the medical fraternity will not accept it. The reason is that this is sort of posterior, in the sense this is about survival of patients who have pneumonia and asthma. Their survival rates have been found to be much higher than pneumonia patients without asthma, because if a pneumonia patient who has a case of asthma comes, for doctors, it's a case of very high risk, okay? And therefore, those patients are given critical care and they recover because of the special attention those patients receive as compared to other patients who don't have a case of asthma. Now you see, it is not that this case is low risk, but their survival is small. Okay? But the AI concluded that they are low risk because their survival is small. So when you apply algorithms in different domains, okay, there will be serious concerns. Here it is health, okay, and life and death. Okay, so therefore, it is very important to build AI systems responsibly, so that they are also interpretable and explainable. Okay, so known as XAI, interpretable and explainable AI. There are certain keywords associated with this, which I have given here: understandability, comprehensibility, but interpretability and explainability are key concepts. Okay, what is interpretability? Interpretability is the ability to interpret a model. Okay, what is a model? Y is a function of X, where it is related by a linear relationship. The slope is B and the intercept is C. Okay, that is what the model, you describe the model. Okay, it is interpretable. Okay, and what it means. Okay, so for example, if B is having a positive sign and it is 0.5, so you will say if X is X, it gets multiplied by positive 0.5, and that will be Y, of course, added the intercept value. So you can actually explain it to a human. Okay, you can interpret it to a human. It's interpretability. Okay, but explainability goes beyond that. It's okay when you use this model for decision making. Okay, there is a decision outcome. Okay, and you have to explain that decision outcome to someone who is impacted by that decision. Okay, so it is not just about interpreting the model, but also explaining why the output is so, and why the output is not something else. Okay, this needs to be explained in the context of a decision. Okay, for example, if the incentives for drivers of a Uber is decided by an algorithm and not by an HR manager. Okay, the algorithm needs to be explainable, because otherwise it may lead to labor problems as to why somebody received less and why somebody received more. So decisions based on AI should be explainable because people are impacted. Okay, so not just interpretable, but also explainable. Okay, so we also saw the case of explainability in the previous example as to why the model actually suggested that pneumonia patients with asthma have low risk. Okay, there is a need to explain. So the problem here really is that the neural networks, and particularly advanced neural networks, are not interpretable and not explainable. They're not interpretable nor explainable because some of those models, like deep neural networks, have hundreds of hidden layers. You haven't learned what is a hidden layer yet. You will learn in the next week. So the more the number of hidden layers, the number of parameters increase. Okay? In a model like this, okay, what are the parameters? B is a parameter, C is a parameter. Okay? And that's it. Two parameters that you estimate. But how many parameters in GPT-4? ChatGPT is GPT-4, up to 1.7 trillion parameters. Okay, with 2 parameters you can interpret a model, but with 1.7 trillion parameters, what do you interpret? Okay? What do you make out of that model? It's a forest. Okay, and it's beyond human comprehension to actually interpret and also explain the outcome. And hence, there is a challenge of using machine learning models, which are AI, which are neural network based, where interpretability and explainability are serious problems. Okay. And when you can't explain a model, how you can actually communicate this to those who actually are impacted by the model's decisions. Okay. That is a key point. Now, here is a chart which shows you the models, or it places different types of models in the XY axis of model interpretability and model accuracy. Okay, so you can see model interpretability is on the x-axis and model accuracy is on the y-axis. What you see here is when you use deep learning techniques, okay, like the advanced neural networks, okay, the model's accuracy is very high. Okay, model performs much better because model is well trained with historic data, and models performance may be much high. Okay, but as you know, the model interpretability is very low. You know, we saw the number of parameters increases. Okay, and therefore the model cannot be interpreted. So when you compromise, when you actually strike a trade-off and come down to rule-based learning, decision trees, regression, etc., models becomes more interpretable. A rule can be interpreted if you have actually really built a model with reasonable number of variables, and the size of the model is controlled, then you can interpret and explain the model. But what is compromised is that the model may not be the best model. Okay, an ANN model may perform much better. Okay, so there is a trade-off between model interpretability and model accuracy. So what should a researcher choose? Well, that is a choice based on the context. Okay, where you apply the model. Okay, in situations where accuracy is the only important thing and interpretability is not important, okay, you can go for deep learning models if you are sure. In situations where interpretability is critical, you should not go for uninterpretable models like the deep learning models. You may actually go for linear models. Okay, so we already discussed bias variance trade-off, which is model flexibility versus model generalizability. Here it is model performance versus model interpretability. Okay, these are important discussions, okay, or debates within the machine learning community today because of the emergence of AI and it's being deployed where humans are substituted by algorithms, and there are ethical aspects to it. Okay, so that's a short discussion on ethics of data and ethics of AI and ML, and you can find more resources in the websites of the tech giants like Google, Microsoft, Amazon, Meta, and in India, okay, NITI Aayog has posted something on responsible AI, which is very specific to facial recognition algorithms. Okay, so but this is a topic that should go hand in hand with analytics and data science, because whatever you build will be deployed, and when you deploy it, it will have societal impact. All right. Any questions on any of the slides which I used? Do you have anything I should explain to you from these slides? Hello?
Hello, sir.
Yes.
This is Rajiv Salahuddin. I'm working as a senior analyst for the last 8 years. I just want to know that what is the use of AI in terms of analytics? For example, if you're working on some analytics tools, maybe like Power BI or anything, so how can we integrate AI in that tool?
Yeah, see, AI is a system, whereas analytics is an algorithm, right? So what functions in a system, like an AI system, think of your Alexa, okay? Alexa is getting trained, but Alexa comes as a whole system, right? It's a physical unit, okay? It has an embedded algorithm, which is trained by data. It's listening to you, right? And it knows it's actually, learning from your own historical data, right? So in other words, ML, the algorithms are embedded within artificial intelligence systems.
Okay. Sir, I have one more question. For example, my course is business intelligence and analytics. So,
Yeah.
does analytics consist of like tools, Google Analytics, Adobe Analytics, or yeah? Is there any another analytics tools we can learn?
See, there are two aspects. One is this course actually deals with data analytics. Okay,
Yes.
how you can use data to draw insights from data. Correct. So essentially, you are learning methods, techniques, algorithms from statistics and computer science. Now, this is one part of it. It's like the engine. Okay, you look at a bus or a car. Okay, the thing that drives the car is the engine. Okay, so you're learning the engine, but the car is the whole thing. So an AI, I would say, is like the car. Okay, it runs on algorithms, but it has more things like the human machine interface. It has an interface where you interact with that system. Okay, so it has more elements, and AI will have more components to it to make it a whole system. And but the engine, the main part of the AI system is the algorithm. Okay, an algorithm is trained using data. So that's the connection we are making here. So for example, Alexa is algorithmic. Okay, and Google Translate is algorithmic. Okay, it's at the end of the day, it's a NLP. It's an algorithm. Okay, which is
Okay.
translating one to the other. You will be learning NLP partly in the last.
Okay, sir. Thank you, sir.
You're welcome. Okay, if there are no more questions, then I will take
Hello, sir.
questions, if any, related to the course as a whole. Okay, if you have any concerns, you can actually let me know.
Sir,
Hello.
there's a question from Rishabh in chat box.
Say that again.
There's a question in chat box.
Okay, sorry, I'm going there. Okay, a lot of good afternoons and thank you. Good afternoon to everyone. So one question from Rishabh is, where can we find the business case studies to deepen our concepts learned? Are you talking about the case study materials that were used in the course?
Uh,
I assume so.
that too, sir. But some more case studies to implement our learnings, like whatever we learned, like the case studies you talked in the classes, like AT&T and others.
Yeah. It's already told in the beginning that the case studies as a whole need to be purchased because these are Harvard Business School studies, like the Pilgrim Bank and so on. But what is available in the course outline posted in the NPTEL site, I have given you a reference to a lot of data sources, okay? Which, for example, you have got, give me a moment. Let me go there. Yeah. So if you go to Swayam site where the course is posted, you can see in the course weekly plan. So you have books to refer, and then you also have at the end references and data sources. Rishabh, you can go there. It is just before appendix. So there I have posted data sources. Okay. So adventure work cycles, which is a data, of course, used for demo purpose only. But there are some online sources which I have shown there. UCI machine learning repository. Okay. So University of California, Irvine has a site dedicated for machine learning pilot data sets. Okay. So they provide you data sets and metadata, and also some brief description about what the data is. Okay. So there are several domain data they have shared there. So that is one side where you can go and apply yourself. Okay. So I would treat them as role cases for data analytics. Then the other is Kaggle. You must be familiar with this platform, Kaggle. They conduct experiments, they conduct competitions, they provide pilot data sets. So that is another side where you can actually get data. The third is the textbook site, Introduction to Statistical Learning, ISL, has a website, a companion website, which is also given there. There also you get certain data sets, okay, which can be used for sort of learning what you learned in more depth. Does that answer your question?
Yes, sir. Sir, thank you very much. I just had one more question. Recently, I came across a term called synthetic data generation. So, how does this tackle the ethics problem?
Um, I would assume that synthetic here means actually organic and synthetic. So synthetic is actually, artificial. So they are not real data. So it could be simulated data. Okay. So you can, for example, use random number generated to generate a lot of random numbers. Okay. But you can actually generate data with some distributional properties. So these are all what we call as simulated data, which are not real data, but data with certain characteristics. Okay. I would say, so long as you are in the laboratory, in order to learn an algorithm, you can use that data. But we do not know whether this data or models which are trained using such data can be deployed in practice. Okay. So they are useful for learning purpose, but may not be useful for application.
Okay, sir. Thank you very much.
You're welcome. Okay, I don't see any other question, and I'm very happy there are no questions. That shows that you're all fine. And if there are no more questions, we will close here. Maybe I will wait for a minute. Maybe we'll close at 12:50. It's 12:47. So a couple of minutes more. If you are still having anything, you can ask. Otherwise, we will close in a couple of minutes.
Sir, this is Rupesh here. I have total 13 years of experience.
Yeah.
I'm working as a data analytics. So I have a question on the subject on the cluster, hierarchical cluster. So we have different types, single linkage, complete linkage, and composite linkage. So I would like to understand what is
Complete
this?
linkage, not
Yeah.
composite linkage. Uh, single, complete, and centroid. Okay. True. Yeah. Yes.
Okay. So I
You're
would
talking
like
about
to understand.
clustering, right?
Yeah, clustering. What is this word clustering, sir?
Watts method, of course, it is explained in your textbook, and I gave you a brief in the lecture also. Watts method is a hierarchical clustering method. Okay.
Mhm.
And it is a hierarchical clustering and not a partition clustering by partitioning like the k-means. So essentially, in Watts method, it is different from single linkage, complete linkage, etc. These are actually methods to determine distance between clusters. Okay, the single linkage, complete linkage, centroid method, etc., are methods to compute distance between clusters. Okay. But in Watts method, the way the algorithm functions is it tries to minimize the square root of the total intercluster distance, if I recall correctly. Let me actually open the PowerPoint.
It's in week 9.
Yeah, I will check that.
If I can give the slide number.
So I have given the formula there, right?
Yeah.
It is using it is a minimization function. Okay, the way actually the algorithm progresses is basically to minimize the total within cluster distance. If you look at that slide, clustering algorithms, you can see a formula is given. Okay, so the sum of the squares of all inter-object distances in all clusters is calculated. So it's a total within cluster distance that the Watts method seeks to minimize. And that's algorithm. Okay, that is the algorithm. So in the example that I discussed to demonstrate you how hierarchical clustering, like the agglomerative clustering functions, we were trying to look at the average distance. You remember in
Yes, sir.
slide 9 of clustering, overall similarity measure, okay, which is nothing but an overall average that we took, okay. It's just an average distance. Whereas in Watts method, it is a sum of the squares of the distances, you see.
Okay.
The squared error, total squared error is calculated instead of the average distance. Okay, so it's a different measure that they use to minimize. That is the difference.
Okay.
Right?
Yeah. Thank you so much.
You're welcome.
So, sir, is this the last live session, or you will have
That is
more?
true. Yeah. This is the last live session because only 2 sessions more, and then you are going to give the examination. But still, if you have any questions, you can of course post that in the chat box. We'll be responding to that.
Okay, cool. Thank you so much.
Yeah. I don't see a need for another session because the coming sessions are also detailed in the sense the lectures are self-explanatory. And if you have questions, we will address them through email. Somebody has asked how to merge 4 to 5 years data in Excel. Well, that's a question which doesn't have details. Excel is a very advanced tool. Okay, Excel itself is a course in several schools. Okay, so Excel programming. Okay, Excel using Excel formula. Okay, especially for merge, there is several database type operations you can do in Excel. Okay, by using Excel formula. So I suggest Jyoti that you either credit a course on Excel computing using Excel. Okay, there are different titles to that course. You can search in NPTEL itself. Okay, Excel for decision making, etc. So do a course like that, so that you learn Excel or spreadsheet systematically. Okay, I don't want to give you say like do this sort of an answer.
Sir, this is Rupesh again here. So this is related to the exam. So when we would be getting our hall ticket, and I know it's written 2 weeks prior to that.
Yeah. This question should be answered by the NPTEL technical team. This is not a course related question. So
Okay,
I'm not
okay.
doing that. Okay.
Yeah.
They
Thank
will
you.
answer you. There are two questions which
Sir,
can.
I have one question. For
Yes.
example, I'm working as a senior analyst. So after completing this course, what is my future path? I can say, do I need to move into BI technologies or analytics or anything?
Well, that is something that you must decide. The question is, why did you credit this course?
Uh, to know the basic understandings of BI, like analytics. What is analytics?
Why should you know that?
Sorry, not to miss-
Why should you know that?
Actually, I have searched on Google like the market of business intelligence, analytics, data science. Is now on a booming
No.
stage.
So what I'm saying is there can be two interests. One is pure academic interest. You want to learn something new. Okay.
Yeah.
Then it is not linked to career. But if it is
Okay.
career interest, then you should know, what is your current job function, and do you have opportunities for analytics in your own organization? Can you start
Okay.
connecting with them because you have done a course from IIT Madras,
Yeah.
NPTEL? So it adds value to your CV and you know things. So try connect with the internal analytics organization in your own company. Many organizations have analytics as a practice, analytics as a business unit, and so on. Okay. So that is where you should start connecting. But if you want to change or seek a new job, then actually you have to look out for opportunities. There are many platforms which help you for professional networking. Like LinkedIn is the best example. You should actually,
Okay.
be there and get to know opportunities. I don't do that. I'm a teacher, right? So, so I'm not searching for a job opportunity. So I may not be very updated on that. Okay, but you have to, put efforts to sort of connect with the world of practice and see where the opportunities lie. Of course, look at advertisements that come for job openings, and keep trying. Okay, and when you go for an interview, for example, then you may get beaten up because you couldn't answer many questions. That is the best time for you to come back and actually learn more. Okay, what is lacking in you? Okay, so it's a process through which you will finally find your career. Okay.
Sure, sir.
Good afternoon, sir. Hello. Good
Yes.
afternoon, sir. So
Good
it is
afternoon, Jay.
Jayavardhan. It is Jayavardhan, and presently I am working as a energy portfolio manager. So one
Yeah.
thing that I face is to how to calculate the demand of the
Demand of
distribution discom, sir, of a state. For example, demand of a state. I have last year 5 years demand with me, and that way I am facing challenges, sir.
Right. You are actually talking about a specific business problem. And this actually is related to marketing. As I said in the beginning, how do you build models? Okay. So what are the sources at which you look at? Okay. So one is, talk to experts. Other is look at literature. So in this case, about modeling demand in different domains, there is actually methods available at textbook level. Okay. The marketing mix models, okay, if I recall faintly, the 4 Ps, okay. There are standard methods developed in marketing literature for demand modeling, okay. So there is no substitute, but you actually familiarize yourself with fundamentals of marketing, okay. The marketing mix models, pricing, there are actually literature available on this. It's more than analytics. This is actually is a field of knowledge in itself. Okay, so you may have to do a course, or you may have to actually, learn from textbooks.
Sir, may
I'm
you
not a
suggest?
marketing expert, so this pertains to marketing and operations, the topic that you're discussing.
Okay. May you suggest any text, sir?
If you can write a more detailed email as to what is the problem you're describing. Okay, I just have only a very limited understanding. Write a detailed, if you can write a paragraph about what's your problem, then we will try to sort of respond to you, say maybe suggest a textbook, or we can do that. Okay, write a mail.
No. Thank you, sir.
Okay.
Thank you.
Okay. Okay, now it is 1 o'clock. So I hope most of the questions are taken, and you asked about career and Excel and so on. There is nothing but left except a thank you. So thank you very much for joining today. And I want to wish you all the best for the sessions that is left, and also for the final examination. Prepare well and do well, and make the best use of your learning in your practice or in your career. All the best. Thank you very
One
much.
more thing, sir. Sorry, sir. One more thing, sir. Question will be subjective or objective, sir?
Objective.
Okay.
All
Thank you.
objective questions. Okay. Thank you.
Thank you, sir.
Thank you, sir.